Alright, let's make this full size. Alright, good morning everybody. This is the assignment for January 6th. Both January 6th and January 7th, depending on which day you have physical science. But anyway, so this is the second assignment of the first week back after winter break, and we've been talking about states of matter, how particles move in each state, and density in the states of matter. We've been talking about that for a while. So now we're going to talk about energy. So in general, energy is how fast something is moving. So a car driving at 60 miles per hour has more energy than a car driving at 10 miles per hour. Now, when we are talking about particles, the energy of any substance is based on how fast the particles are moving. We call this form of energy thermal energy, and we measure it with temperature. You'll probably understand temperature. You take your body temperature, and as you usually cook things, you are adding thermal energy to them and increasing the temperature. You need to bake something, usually set the oven at 350. That's the temperature. Now, temperature is a measure of thermal energy. Thermal energy is how fast the particles are moving in any substance. So temperature is how fast the particles are moving. So if we take a look at this GIF right here, on the left in this red box, the particles are moving really, really fast. And so it has more thermal energy. And if we were to take the temperature of this substance, the temperature would be higher. Over on the right, in the blue box, we see that the particles are moving slower. Therefore, it has less thermal energy. And if we measured the temperature would be lower. Now, what we should know when we take a look at both of these boxes and compare them, these are probably gases. Notice the particles are spread out. They are filling the entire container. So these are likely gases. And we know that within each state of matter, solids, liquids, or gases, you can increase the temperature up to a certain point. You take water and you can set it on the stove and you can increase the temperature of it and make it hotter and hotter and hotter. Eventually, you're going to reach that point where it changes into a gas and it becomes steam, right? So yeah, so comparing the different thermal energy of different substances is really just about how fast the particles are moving. And this is a gas. Now, if we're talking about solids, remember the particles in a solid can vibrate. So when you increase the thermal energy of a solid, what's happening is those particles are vibrating faster, 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 faster. Eventually, when you get to the melting point, instead of vibrating, those particles are going to sort of break out of their position and be able to slide around each other. So after that phase change from solid to liquid, we increase the thermal energy, we increase the vibration or the movement of those molecules until we reach the state of a liquid. And just like a liquid, same thing happens. We increase the temperature, the molecules move around faster, 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 until eventually they have enough energy to become a gas. All right, so there's your more and less thermal energy. More movement of particles means more thermal energy. Less movement of particles or slower movement means less thermal energy. So faster movement, higher temperature, slower movement, lower temperature. So taking this information based on what we just learned, which state of matter do you think has the most thermal energy or the highest temperature? Your options are a solid, a liquid, or a gas. Your sentence frame should be the state of matter that has the most thermal energy is, and then put in solid, liquid, or gas. If you want a level 4, you need to say because afterwards. So the state of matter that has the most thermal energy is, pick one of these, and then say because, and explain why you wrote that answer. That's all we have for our assignment today. If you have any questions, please ask them during your class period, or show up to office hours and I can work on them with you. Take care, everybody.